Hi everybody, welcome to another section in Math 1324, section 4.1. On this section, we just review system of linear equation into variables. So system of linear equation. So linear equation, we have just x and y that is raised to the first power. So it's like that, it is a linear equation. Now when we have more than 2, that is the system of linear equations. If we have 2 variables, usually we're going to have 2 equations. So we have the system of 2 linear equations. And if there is a set upon x and y that satisfy the equation, we conduct the solution to the system. So the solution is whatever satisfies the equation, any pair of x, y that satisfy the system of equation. Right, let's see how that works. So in this section, we will solve the system of equation 3 different ways. The first one by graphing. This is not very practical, but we still need to solve that because it has significant. So just take a look at this first equation. X plus y equals 32. And just like when we graph a linear equation, it is a linear equation, meaning the graph is going to be a straight line. And if it is a straight line, we choose 2 points. 2 points, connect them, we have a line. And if it's an equation like this, it will be a lot easier if we just choose one to be 0 and the other one will follow. So we have a pair of x, 2 pair of x, y, that's what we need. So easy, we can choose x equal to 0 and then y equal to 0. Right. When x equal to 0, we have 0, 2 times 0, x is 0, plus y is 32. So in that case, y is equal to 32. Now if we choose y to be 0, we have 2x plus y is 0 equal to 32. Now 2x is 32, so x is equal to 32 divided by 2 is 16. So have 16 and 0. Right, we'll graph that in a bit. Now just focus on the other equation. X plus 3y equal to 36. Now we choose x to be 0 and choose y to be 0. Now x is equal to 0, we have 0, and then 3y equal to 36. Divide by 3 on both sides, we have y equal to 12. And when y equal to 0, we have x plus 3, y is equal to 0 is 36. So x is equal to 36. Right. So the reason that we don't graph the line immediately, because we have to know what are the points are. If we choose the x happen to not be big enough, the point here will not be enough to graph it. So we have to look at this. When we look on the x values, it is 16 and 36, so we have to do something that's big enough, so we have the point on the graph, because the coordinate here is blank. Here on the x and y, also we have to do something big enough to accommodate all of the numbers on the coordinate system. So we have to do something that is the biggest. X values would be have to go from x has to go from 0 to 36, and y has to go from 0 to 32. Something bigger than that range. So obviously 0 is going to be right at the corner. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so we can choose 4 each because 40 will be big enough to do this. So 0, before 8, 12, 16, 20, 24, 28, 32, 36, and 40. Right? 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Right. Now we have 0 and 32. X equal to 0, y equal to 32. X equal to 16, y equal to 0. So we have these 2 points. And 2 points will form a line and linear equation. So the equation is, the graph is a line. So this is what we have. And then next we have 0, x equal to 0, y equal to 12. And x equal to 36, y equal to 0. And we have to draw that almost perfect to get the answer. So it looks like 12 and 8. So we say solution. We have x equal to 12, y equal to 8, or we write as the pair 12 and 8. Right, like I said, this had to be perfectly drawn, and we actually the point look, it's easy to see the intersection. So obviously this way we require, because have the straight ruler, so that it's not always optimal to solve like this, but it just so that it can be done. Right, when all the circumstances, all the numbers look nice. If we have fraction, if we have decimal, then of course the graph is impossible to tell if it is the solution. Right, type of solution. Now the reason that we solve the equation by graphing, because we know that linear equation is a line. Now given 2 lines on the plane, there can be intersection. So in this case there's one solution, or they can be parallel. If they're parallel, there will be no intersection, there's no solution. And we can have 2 lines that are identical, so in that case infinitely many solutions. So in that case we have 3. The reason we study the graphing method, so we can say that there will be 3 scenarios. We have one solution that's called the independent system, one solution. So we have graphically it is going to be intersecting line. Inconsistent, when they have no solution. No solution is where we have no intersection. So we have 2 parallel lines, intersecting lines. Inconsistent will be 2 parallel lines. And dependent, or infinitely many solutions, we say identical line. The lines are identical. Right, so that the first part of the section, solution by graphing. Now, next we solve the equation by substitution. So substitution, just by the name of it, we will to solve for one variable in terms of the other, and then substitute into the other equation. So that let me write that out. Solution by substitution. So what we actually do is solve for one variable in terms of the order. Then substitute into the equation. So we have equation number 1 and 2. Right, now just pick one equation and then we solve for that variable. Now if we look at this variable, 1 for x, 2y for x, and 5y, if we have to solve for the x here, is the easiest one to solve for. So on the big scheme of things on the equation, whatever the variable that have only coefficient of 1 or -1, that preferably, that's what we would choose. So in this case, I would choose, I would need to write out the step. So we say equation 1, solve for x, or solve for x. So for x in equation 1. So x plus 2y equal to 3. So minus 2y. So we have x equal to 2y, 3 minus 2y. Then we can substitute that into the equation number 2. Substitute this into equation 2. Since we use 1 to solve, we have to use the other to solve. Substitute into the other equation. Right, so equation 4. And now we have x is 3 minus 2y plus 5y equal to 6. Multiply that out, 12 minus 8y minus 5y equal to 6. Negative 8y plus 3y is negative 3y. And move the 12 to the other side. We have negative 3y equal to negative 6. And divide by negative 3 on both sides. We have y equal to 2. Now that we know y equal to 2, the rest is easy. X equal to 3 minus 2y. So we have lastly x equal to 3 minus 2y, and y is 2, so 3 minus 2 times 2, so 3 minus 4 is minus 1. So x equal to minus 1 and y equal to 2. Right, so that's what we have. I'm sorry, should write that as a pair. So that there's one solution that is the pair of negative 1 and 2. Right, so that's simple enough. Now we take a look at this equation. So in this equation we have 3x, 2y, 2x, and minus y. So if we have to pick one to solve for, the y here is easier to solve for because the coefficient is negative 1. So we go for the coefficient that is 1 or -1. That is easier to solve for. So equation 1 and 2. So first we will solve for equation 2 and solve for y. So 2x minus y equal to -6. And we solve for y. So get y by itself. That case, the y is negative here, so it's easier to just move to the, if we add on both sides, the y will become positive. Of course, you can just move the 2x and then divide by -1. Either way, get the y by itself. So we just do that first. So it's 2x equal to -6 plus y. And then we get plus 6. And that gives us 2x plus 6 equal to y. So that is the substitution y equal to 2x plus 6. Now the substitution, we will substitute into equation 1. So 3x plus 2y, y is being 2x plus 6. Equal to -2. Now just solve for it. So that gives us 3x plus 4x, and we multiply it out. Plus 12 equal to -2. 3x plus 4x, that's 7x, and we minus 12 on both sides. So that gives us -14, and divide by 7. So x equal to -2. And now we're just going to solve for y equal to 2x plus 6. Because we already know x. Now we just need to solve for y. So we're going to put -2 in for x. So -4 plus 6 is that 2. So we have x equal to -2 and y is equal to 2. That is the solution. X equal to -2, y equal to 2. Of course, we should check our answer too if we want. Put -2 in here and put 2 in here. 3 times -2 is -6. 2 times 2 is 4. -6 and 4, -2. So that's good. Now -2 and 2 in here. 2 times -2 is -4. -4 and -2 is -6. So that's good. So we need to check the answer like that as well. Right. Now on to this equation. Now this is nice enough. We already have the substitution. We don't need to go any further. Just use it. So in the first equation, we already have x equal to 6 minus 5x, and we're just going to add and use it. Now we substitute that into the, this is what on the second equation. Now we're going to use this and substitute into the first equation. Doesn't mean that should be y, sorry. 6 minus 5y, and we substitute that into the first equation. So that gives us x is 6 minus 5y. Plus 5y equal to 7. Now 6 minus 5y plus 5y equal to 7. 5y and 5y cancel out, we have 6 equal to 7. Of course this is not possible, so in that case there's no x and y that satisfy the equation, so we say no solution, because this form for every x and y. So we have no solution. Now we solve the equation by elimination. Elimination is actually more versatile. We should prefer elimination over substitution when things get more complicated. A system of linear equations is transformed to equivalent system of if two equations are interchanged. Equations multiplied by a non-zero constant, and the constant is multiplied is multiple one equation is added to another, right? So we use that. So interchange, if we have two equations out like this, if we interchange, the solution will not change. So that's one obvious. If the whole equation we multiply by a constant, if we multiply this by 5 or something, the solution will not change. And finally, the last one is a bit more complicated. We multiply and then we add to another equation. So we multiply by some number and then add to that. Right. Yeah, that's just right. Again, it's useful to denote equation. So you have x plus 2y equal to 3, and 4x plus 5y equal to 6. Now we try to eliminate x or y. Just have to pick one, and we can eliminate x, eliminate y, or it doesn't matter. I will choose to, let's say, eliminate x, because that looks easier. Because again, we prefer eliminate the one with the coefficient is 1 or negative 1. So we say eliminate x. So we try to get the coefficient by itself. The way we do this is we multiply the top equation by something and the second equation by something. So if we multiply by negative 4, so multiply by everything by negative 4, so we have negative 4x, negative 8y, and negative 12. And then we have 4x plus 5y equal to 6. I don't know why. Equal to 6. Yeah, in this case, we don't need to do anything, or we just say multiply by 1. So usually we multiply by something so that the coefficient will have opposite side. And so when we add both sides, the 4x cancel out, we have negative 3y equal to negative 12. plus 6, negative 6. And from here we just divide by negative 3 on both sides. So we have y equal to 2. Once we know y equal to 2, we can substitute in either one of this and we solve for x. Again, if we put 2 in here, of course we can solve for x, but that for x is more difficult. So we prefer to go with the similar coefficient. So we're going to solve for this x. So substitute. And we have y equal to 2. Into the first equation. And y is equal to 2 equal to 3. So x plus 4 is equal to 3 minus 4. So x equal to negative 1. So we have x equal to negative 1, y equal to 2. So the solution is negative 1 and 2. Right. Now we have a word problem. So word problem is a math problem. We just translate the words into math, and then we just solve the math problem. That sounds a lot easier than said than done. Right. And look at the problem. See what we did with. So a man walks at the rate of 3 miles per hour and jogs at the rate of 5 miles per hour. He walked and jogged the total distance of 3.5 miles. He 0.9 hours. How long does he walk and how long does he jog? But a few background here. So it's simple physics. Distance is equal to the rate times time. So that the background here. Now usually when we solve the word problem, we have to know what we're solving for. So if we solve for we have to denote the variable. So how long? So the question asks for time. How long does he walk? Let that be W. And how long does he jog? That would be J. So W and J would be the time that that person walks. So we say that's what we start with. Let W be the time that he walks, and let J be the time that he jogs. Right, but the speed walk at 3 miles per hour and jogs at 5 miles per hour. Right. Now, because this is the time that he walked and the time that he jogged, and instead he said he walked and jogged total distance of 3.5 and in 0.9 hours. So because in 0.9 hours that's the total times. So in that case, what we have directly from that, we have W plus J is 0.9. That equation with regard to time. Now, if we talk about distance, total distance of 3.5. So 3.5 total. And so we have distance is the rate time. So distance is equal to the walking distance and jogging distance. The distance that he walked and the distance that he jogged. Right. So he walk is the rate times the time. The walking rate is 3 miles per hour, and the time that he walk is W, and the jogging distance is 5 miles per hour, and the time that he jog is J. The total distance is 3.5 miles. So we have the system of equation. This is 1 and 2. So let's just write W plus J is equal to 0.9, and 3W plus 5J is 3.5. So let's use elimination. Again, we have coefficient here 1 and 1, so we can eliminate either one of them. I try to eliminate J. So eliminate J. Go with that. So we will multiply by something so that the coefficient will be we cancel out. Coefficients 1 and 5, the multiple of 1 and 5 are 5. So if I just multiply by negative 5, it will work. That gives us negative W, negative 5W, negative 5J, and deal with that, negative 4.5. And then the second equation, we just don't need to do anything. Just multiply by 1. .5. And we just add side by side. So that minus 2W is equal to minus 1, and divide by negative 2 on both sides. We have W equal to 0.5. Then we can substitute that into the equation and solve for the other variable, which is J. Now we substitute that into this equation. Now substitute W equals 0.5 into equation 1. So we have 0.5 plus J is 0.9, and we minus 0.5 on both sides. So that's why we have J is equal to 0.4. So J is 0.4. And so W, the time that he walked is 0.5 hours. 1 hour is 60 minutes. So 0.5 hours. So that 0.5 times 60, so that 30 minutes. And jogging is 0.4 hours. And then times 60 will be 24 minutes. what we have. Next, we have suppose that we have this solution, and one is the supply and one is the demand, and the question is which one which. But the answer is easy. When we look at this, the supply, if the price is increased, you will more willing to sell that as a company, because as a supplier will give you a lot more money. As a demand from the consumer perspective, the cheaper the price, the more willing to buy. So just based on that. So in that case, if the quantity increase, the price increase. So both of them positive. If the quantity increase, the price will decrease. So this is the supply, and this is the demand. Supply is the higher the price, the more willing to sell, or the more quantity possible, the higher the price. So that will be supply, and the other one is demand, to go opposite. The price and the quantity will be opposite direction. Right, so find equilibrium. So just solve the system equation. And write like that, so this will look like number 9. So if the equation like this, if you just subtract side by side, we cancel the p. Right, that works. Or we can just use substitution and substitute one into the other. That also works. So substitute and elimination is both variable here. I've just used substitution. So we substitute. Let's say we substitute this. We use this equation. We use that first equation, so we substitute into the equation number 2. And then we just solve for Q. And 1.85. And then we need to move that number to the other side. And then we take that, we divide by 1.85. I'll just end up with that. So Q is equal 7.854, and this is Q in thousand. So in that case, we have 7,854 cases of live bones. And then now after that, we solve for the price. Then we substitute. Of course, both of them equal to for p, so we can just substitute in either one of them. Just use the first equation. because I'm going to deal with this negative. Actually, we just substitute into this, because that's what we have, P equal to. P is equal 1.138. Right. We didn't have the clear unit for P in this case, so we're just going to leave with that. So we have the solution will be Q and P. Q equal to that, and this is P equal to that. Right. Next, Jasmine want to use milk and orange juice to increase the amount of calcium and vitamin A, and 1 ounce of milk have 37 milligrams of calcium and 57 microgram, that is the microgram of vitamin A. 1 ounce of orange juice. Okay, because you can read the problem. Now, if you need 5 milligram of calcium and that much vitamin A, how many of each should she drink? Right, so later on for this type of problem, we should summarize like this. So you have 2 types of drinks, orange juice and milk. Right. Milk add to that M, and then orange juice. Orange juice HAOJ, and let's use some variable. I don't want to use O because that looks like number 0. Add to J again, J. Right, so we have those 2. Let's see what this to offers. The milk, we have 2 types of nutrients here, the calcium and vitamin A. So calcium and vitamin A. So the calcium here, for the milk, there are 37 milligram of calcium and 57 microgram of vitamin A, and for the orange juice, 5 milligram of calcium and 65 microgram of vitamin A. In total, see, we need 512. Of course, we're not going to add straight up, and it's not going to be like that. What we have is that is for 1 ounce. So we have, of course, you have to drink more than 1 ounce. I assume that makes sense, right? So in that case, we have to multiply 37 by M. So that's how many ounce, how many calcium you can get from milk, and 5 times J, that's how many you can get from orange juice. So we have 37 m plus 5j equal to 500. 57 m plus 65j equal to 1200. I show that. Now we try to solve for one of them. Now look at all of this equation, and the coefficient that is the smallest, easiest to solve for is the j. So we try to eliminate that and solve for j. So eliminate j. The question is how many L's that we should drink. So this is in terms of ounce. M ounces and J ounces of orange juice. So we try to eliminate J. So what we need to multiply in here to get them equal. So we try to get to the same number. Right. Now let's say if, okay, hypothetical, if you want to eliminate m, the easiest way is just multiply by 57 multiplied by 37. If we just flip the numbers, then we can eliminate m. We flip the numbers and change the sign of one of them. So if you multiply by 57 on the top and negative 37 at the bottom, those numbers will be the same that we just add both sides. But here we have 65 and 5. Of course, an easy way is just multiply by 65 on the top, multiply by negative 5 at the bottom. But it's even simpler than that, because 65 divided by 5, 65 divided by 5 is 13, so we're going to need 13. If we multiply by 13, that will be equal, right? Okay. Actually, it should be negative 13, but I said perfectly fine. Just 13 times 37, and we have 481. And that will give 65 J. And 13 times 500. And we have 6500. And then the second equation we multiply by negative 1. That gives us negative 57m, negative 65j, and 1200. Yeah, so we keep the coefficient 1 positive and 1 negative. It will be easier to add. In that case, combine both sides. So we have 41 minus 57 at 424m. And then we add this. That's 77 hundredths. And now we divide by 424. Sorry, I make a mistake. We multiply by negative 1, right? So this should be minus. And that gives us, 5300. And now we have 5300 divided by 424. That's more like it. So m is equal to 12.5. And now we just need to solve for j. We can just pick one of this and solve for j, and so the coefficient will be easier on this 5 j. The coefficient is smaller, so we're going to go for that equation. So substitute m equal to 12.5. into the first equation. M is 12.5. I'll multiply that out. Give us 462.5 plus 5j equal to 500. Minus 462.5. So we have 5j equal to that. $37.5. So divide by 5 on both sides. So j at 37.5. Oh, sorry, divide by 5. $7.5. So we have to drink 12.5 ounce of milk and 7 ounce of orange juice. And with that, we finished section 4.1. As always, thank you for watching, and see you in another video in Math 1324.